Recently, we talked about a neural network called GPT-3. This week, OpenAI announced a key endpoint for GPT-3 embeddings that allows users to derive dense text embeddings for given input text at allegedly a state-of-the-art performance on several relevant tasks. Dense text embeddings are useful for many tasks, including clustering, topic modeling, duplication, paraphrase mining, and semantic search.
Interest in neural networks is growing, and there are more questions as well as research. As part of one of his studies, Niels Reiners worked on dense text embeddings since 2019 and released his research as part of the Sentence Transformers framework, which provides open and free state-of-the-art text embeddings models for many use cases. OpenAI provides 8 points for 3 different use cases. Text similarity, for example, useful for clustering, deduplication, and topic modeling. Text search, for example, useful for retrieving information from a large corpus. Code search, for example, useful for finding a function for given search query.
His main task was to investigate how well with GPT-3-based embeddings would work, so he benchmarks the text similarity on 14 datasets and text search embeddings on 6 datasets from various domains: Twitter, Reddit, Stack Exchange, emails, news, scientific publications, and many more. Initially, the researcher was really excited about the new version of OpenAI, but the result of his study showed the opposite.
The OpenAI text similarity models perform poorly and much worse than state-of-the-art models. In fact, they perform worse than the models from 2018, such as the Universal Sentence Encoder. They are also 6 points weaker than extremely small models with just 22 million parameters that can run even in your browser. The text search models perform quite well, giving good results on several benchmarks. But they are not quite state-of-the-art compared to recent, freely available models. The embedding models are slow and expensive. Encoding 10 million documents with smallest OpenAI model will cost you about $80,000. In comparison, using a nucleus strong open model and running it on the cloud will cost as little as $1. Also, operating costs are tremendous. Using the OpenAI models for an application with 1 million monthly queries cost up to $9,000 per month. Open models which perform better at much lower latencies cost just $300 per month for the same use case. They generate extremely high-dimensional embeddings, significantly slowing down downstream applications while requiring much more memory.
All this was the result of a large number of studies on various parameters.
Computational investments were checked, the efficiency of embeddings proposal and baseline comparisons were made with other models.
Additionally, the performance of text search was examined and it was found that OpenAI models perform comparably with open dense models. However, the biggest difference is the cost.
In addition, the study touched on coding costs and operational costs as well as operational costs, where once again the high costs and quite large costs were confirmed in comparison with other models which don't differ in the number of parameters the efficiency from OpenAI.
Overall, the study found that the text similarity models are weaker than, for example, Universal Sentence Encoder from 2018 and much weaker than text embeddings models from 2021.
They are even weaker than the all-mini LM-L6v1 model, which is so small and efficient that it can run in your browser. The text search models perform much stronger, achieving good results, but they're just on par with open models like SplitV2 or multi-component-based .v1. The biggest downside for the OpenAI embeddings endpoint is a high cost, about 8,000 to 600,000 times more expensive than open models on your infrastructure. The high dimensionality of up to 12,000 dimensions making downstream applications slow, and the extreme latency when computing embeddings, which hinders the actual usage of the embeddings for any search applications.
Let us in the comments what do you think about this kind of technology. Subscribe to our channel, and if you want to receive more helpful information, just check it out on brutonlab.com.